We're going to talk about logarithmic functions. If you guys look at your calculator, there's a button on your calculator that says log. Looks like this. It says log. And then above it, if you were to hit like second or something like that, it says 10 to the x power. Those are inverses of each other. One is an exponential because there's the variable in the exponent. And the other one is a logarithmic because it says the word log. There's also another button on your calculator that says ln. That's the natural log. It comes from Latin, that's why the L is first. But it's natural log. And above that is the letter E. All right, E is a programmed number into your calculator. It's kind of like pi. Like when you hit the pi button, the 3.1415. If you hit E, you get like 2.17. It's a specific program value. But these two things kind of are the same thing. Logs and natural logs are pretty much the same thing as exponentials or E, because it's E to the x. So we're going to be talking about going from one thing to another. We're going to change from logarithmic to exponential and from exponential to logarithmic. That's like what we're going to talk about today. Tomorrow we're going to talk about how to solve them in your calculator. So little review of what we're doing here. Everybody in here, if I said what's 2 to the 4th power or 2 to the 2nd power is 4, yes? Is this in exponential form or is this in logarithmic form? What do you see here? An exponent. If something is in exponential form, it has an exponent. If something is in logarithmic form, it says the word log or ln. All right, so that's really easy to determine what's what. This is mathematically how you go from one to the other. You see here, log base b of y equals x is the same thing as b to the x equals y. I'm going to read it a little differently. I'm going to say it a little differently, but I want you guys to understand when you say log and there's a little number there, that's the base in which they're talking about. On your calculator, it just says log, just log. That means it's understood that you're in base 10. So if I had log base 7 of 3 and log base 10 of 3, those two things are not the same because they're in different bases. It's based upon a different numerical value. So just understand that on your calculator, just because you see the word log, if there is a little number here, you can't just hit that button and get the correct answer. We'll talk about how to go from one to the other and all that in a second. So I'm going to do some examples. All right, we're going to go from one form to the other. Sometimes it'll tell you go from log to exponential or vice versa, or sometimes it'll just say to rewrite. What form am I starting off with here? Am I in logarithmic or am I in exponential? How do you know you're in logarithmic? Because it says the word log and there's a little number. Okay, so how do you go from logarithmic to exponential? Every single time we're going to do this. You're going to cross off the word log. The little number becomes your big base. So I'm going to rewrite it as 2. And then these two numbers switch spots. So the 4 becomes your exponent equals 16. Is that a true statement? 2 to the 4th power equals 16? Yes. So every single time you start off in logarithmic, you cross off log, the little number becomes the base, and then the other numbers switch spots. Every single time, no matter what, no matter if it's a fraction, if it's negative, anything like that. So let's look at B. This says log base 4 of 1 equals 0. What do I do with the word log? I cross it off. What does little 4 become? Big 4. And then what happens with 1 and 0? They switch spots. So 4 to the 0 power equals 1. Guys, what's anything to the 0 power? 1. Perfect. Let's go to the next one. What happens with the word log? I cross it off. What does my little 12 become? Big 12. And then what happens with these two? They switch spots. So 12 to the 1st power equals 12. Is that true? Yeah, good. Uh-oh. Does everything change now because we have fractions and negatives? No. What happens with the word log? I cross it off. What does 1/4 become? My big base, right? And then what happens with the 4 and the negative 1? They switch spots. So negative 1 equals 4. think about this. The other ones you could kind of see. If you were going to evaluate this left side, would you agree with me that you would distribute this negative to the top and bottom, right? So I have 1 to the negative 1 over 4 to the negative 1. Guys, if you have a negative exponent, where do you move it to make it positive? To the either up or down, right? So if I move 4 to the negative 1 up, it becomes positive 4. And if I move 1 to the negative 1 down, it becomes positive 1. Does that equal the same thing? There you go. So exactly what it said on the first slide, but it was a log base b of y equals that sort of thing. All you have to remember is when you have log, you cross off the word log. That little base, the little number, becomes your big base, and then the two numbers switch spots. You guys have any questions? All right, let's look at the next slide. Well, wait a second. It says rewrite. Maybe it doesn't tell you to go to logarithmic form, but what do you notice you're already in? We're in exponential. How do you know this is exponential, guys? You have what? An exponent. So exactly what we just did, we're going to go in reverse order. My big base is going to become what? The little number, right? If I'm going to go to logarithmic, I'm going to first write the word log. And then this big number 5 is going to become what? Little. I'm going to write it right here. And then what happens with these two numbers? They switch spots. 25 equals 2. When it says log base 5 of 25 equals 2, what that's really saying is what, how many times can I multiply 5 by itself to give me 25 is what the question's asking. Our brains work better in exponential than they do in log. So if you ever start off with a logarithmic, and it says to evaluate, I'm going to always tell you to go to exponential first. So let's look at the next one. I have a big 10. And I have an exponent. So the first thing I write down is word what? Log. I'm going to write down log. And then what's my little number? 10. Do I have to write the 10? I don't have to. The only reason I don't have to write 10, look at your calculator. It is understood. It's kind of like if you have X, you don't have to write the 1 in front. We are understood. If there is no number there, it's just considered log base 10. I'd get in the habit of writing it just in case, just because. But what do I do now? What do I do with the 0.1 and the negative 1? They switch spots. This becomes 0.1 equals negative 1. Some of us don't really like to think in decimals. It's not our major thing. What's another way I could write 0.1 as a fraction? 1 over what? 1 over 10. Perfect. If you guys wanted to write it like that, you're more than welcome to. 1 over 10 equals negative 1. Either way is fine. That says 1/10, right? If you read that decimal, it's 1/10. Let's look at C. Oh, geez. Don't freak out. What form are we in? What are we starting in? Exponential, and I want to go to log. So the first thing I'm going to do is write the word log. What does this big 8 become? Little 8, good. And then what happens with 2/3 and our 4? So log base 8 of 4 equals 2/3. What that question is saying is, what do I multiply 8? How many times do I multiply 8 by itself to give me 4? So this is why I'm going to tell you guys in a second here. If you started off with this problem, log base 8 of 4 equals 2/3. You guys are like, I don't know. So if I rewrote this exponentially, you'd say, okay, my log goes away, my 8 becomes big, and these two things switch spots. Well, what does the exponent 2/3 really mean? What am I doing to the 8 if it's raised to the 2/3 power? So another way I can write 8 to the 2/3. The cube root of what? 8 squared, right? Well, what's the cube root of 8? 2, and 2 squared is 4. Whenever you start off logarithmically, and it's going to tell you to evaluate, right now we're just switching from one to the other, but if it tells you to evaluate, I'm going to tell you, guys, we think exponentially, so go to exponentials first. Oh, good, we got another one. I see a big 6 with an exponent, no big deal. What's the first thing I write down? The word log. What little number am I going to put there? Perfect. And then what happens with -3 and 1/16? They switch spots. Not 1/16, 1/216. Another good thing to associate here, guys, because we are talking about exponents and stuff like that. When you have a whole number raised to a negative exponent, do you see how this is a negative exponent? What is your answer? Is it a whole number or a fraction? What's 1/216th? Is that a whole number or a fraction? Just be mindful. If you are expressing or if they're asking you to answer something like that and you have a whole number that's raised to a negative exponent, your answer is going to be a fraction. Those are just little things to kind of keep in mind. All right, let's scoot along here. So this says to evaluate. Guys, what does the word evaluate mean? What's the answer? Tell me what the answer is. So I'm going to set all of these equal to x. My brain works better if I have an exponent. I mean, no, it doesn't. Well, it does exponentially, but if I have an equal sign, I can say, okay, if I'm going to evaluate, that means, well, what's the answer? So I can go ahead and do this. So I look at this and I say, okay, what does this question even say? Our brains think better, guys, exponentially. This will make more sense when you look at it if it's written as an exponent. So let's go from logarithmic to exponential. It doesn't say you have to. If you guys already know the answer, cool. I just think it's easier for us if we go from logarithmic to exponential. So what's the first thing I'm going to do if I'm going to switch? Cross off log, right? What does the little 4 become? Big. And then what happens with 64 and x? They switch spots, so this is what it looks like. This now, you guys, what is this question saying? 4 times itself, how many times gives me 64? What's the answer? 3. X equals 3. How can you check it? Well, 4 to the 3rd power equals 64. Is that a true statement? Yes. Some of you may look at that and be like, oh, well, what log 4 of 64 means is, how many times does 4 times itself gives me that number in front? Fine. I just don't think a lot of us think that way, so that's okay. All right, now I look at this, I'm like, oh, it's a decimal. It's a decimal. Well, first of all, how do I think? I think exponentially, right? So I'm going to cross off log, and what does the little 5 become? Big. And then what happens with 0.2 and my x? Okay, so 5 to what power gives me 0.2? Oof, I don't know. How can I rewrite 0.2? Okay, think about this. 0.2, that's 2/10, right? You guys agree? That's 2 over 10, which becomes what? 1/5. Okay, so what this is really saying is 5 to the x power equals 1/5. What did I tell you about ooh, look at you. What did I tell you guys? If you have a whole number raised to a power and your answer is a fraction, what kind of an exponent do you have? A negative. So this is to the negative, x equals -1. Another way you could look at this, guys, because I know some of you are like, huh? Another way you could look at this, I don't want to think of it as a fraction. Do you agree with me that this is to the 1st power? Yeah? So if I moved it up here, my 5 would become what? I mean, my 1 would become what? It would become, if it's positive on the bottom, when I move it up, it becomes what? Negative. So now do you see that x equals -1? Could look at it that way. Either way. But as soon as we start off with the decimal, I'm like, it's kind of easier to look at it another way. All right, let's look at this one. Let's rewrite it exponentially first. Exponentially first. What do I do with the word log? I cross it off and I make 1/5 what? I make it big, okay? And then what happens here? Ooh, I like that. I hear x equals -3. Okay, well, let's think about this for a second. Is there a relationship? A lot of this stuff is thinking, guys. Is there a relationship between 5 and 125? How many times did 5 multiply by itself to give you 125? 3 times, right? So what did I tell you about a whole number? If you have a whole number and then it's becoming a fraction, then your exponent is going to be what? What we just talked about. Your exponent is going to be, oh, thank you. She went all the way to Publix for that. Thanks, honey. I said you went all the way to Publix for that. So your exponent is going to be what, guys? Negative, all right? So think about it. You can also rewrite it like this. I could rewrite this as 5 to the, this is the first power, right? So if I rewrite it up top, does that become negative x equals 125? So 5 to the third power is 125, so that's where we get x equals negative 3. If you don't want to think in fractions, then just move everything to the numerator. All right, let's think now. Let's think. This is another thinking one. What do I do with my log? Cross it off. 36 becomes big, right? And then these two switch spots. You guys know this. Come on. 36 to what power is going to give me 6? What's the relationship between 36 and 6? Okay, I like that you guys are saying 6. So think about it. If I replace this, is 36 to the 6th power 6? No, but I like the way you're thinking. Okay, that's good thinking. What could I do to 36 to make, tell me, to make it become a 6? 1/2, right, because guys, so smart. Oh, you don't like that. I said Jeremiah's the only one that talks to me. Okay, I have to see where we're going. What is 36 to the 1/2? What's 36 to the 1/2? How do you rewrite it? Should say, I'm sorry. It's the square root of 36. Good. So look at this. What we did was we went from a bigger number to a smaller one. The first thing, if it's not like super evident, I would say to myself, what is the relationship? How did 36 become 6? You guys all recognized, oh, 6 times 6 is 36. And then when I actually wrote down 36 to the 6th power equals 6, you're like, oh, wait, that's not true. So, problem solved. Good. How are we doing? All right, let's go to the last. Just kidding. We're almost to the last slide. I already talked about this. Common logs versus natural logs. Same thing. Do you guys see how there's the word log here? These are the natural logs with a little e. We'll talk more about that tomorrow. This is in your calculator. Notice that there's no number here, so it's just considered log base 10. So if you have a calculator handy, go ahead and hit log 8. Tell me what you get to 3 decimal places. 0.9 what? 903. Is that something we could have evaluated in our head? No. Nobody in here could have. Even Miss Carver, who got every single question right in the math portion of the SAT. Everyone. Can you imagine walking out going, I know I got them all right. I cannot. There's some that you guys cannot evaluate by hand, so you have to use your calculator. Look at your natural log button. You guys see ln? Hit ln, and then 0.3. Tell me what you get. 1.20. Okay, perfect. What happens when you hit log -7? Error. All right. What about the natural log of -4? Error. What do you think that's telling you? Can you take the log or the natural log of negative numbers? No? Okay. That's good info to know. All right. Let's look at the last slide. Rewrite. We can do this quickly and then we're done. How do I rewrite? First of all, I'm in logarithmic, so I'm going to go to. If we start off in log, we're going to exponential. So my log crosses off, my little 3 becomes big, and these two switch spots. This becomes 3 to the 4th equals 81, which is true. Let's look at 2. What happens with log? Cross it off. The little 7 becomes big, and these two do what? Switch spots. It's just becoming a little redundant. Good. I'm glad it is. What happens to log here? cross it off. My little 14 becomes big, and then what happens here? Switch spots, so 14 to the 0 power equals 1. Perfect. What about here? Cross off log. 1/2 becomes my big base. And then this switches. You guys agree? Good. I'm going to go down and then over. I'm going to start with 8 here. What form am I in number 8? Exponential, because I have an exponent. So I'm going to go to log. So that means I'm going to write the word log. And my big 256 becomes little 256. Good. And then what happens here? Switch spots. Good job, guys. Number 7. I write the word log. My big 4 becomes teeny. And then these do what? Switch spots. Your homework should be pretty quick tonight. All right, I'm going to write the word log. My big 50 becomes little. And these two do what? Perfect. And then log, big 7 becomes little. And 49 and 2. And try to do 2 things at one time. 49 equals 2. All right, now we're going to talk for 1 second. We're going to do 2 by hand, 2 by calculator, and then we're going to talk about something tomorrow called the change of base formula. It's really easy. Some of these, like I said, we can evaluate in our heads. Some of them we cannot. If it says to evaluate, I'm going to always set them equal to x. For me, it makes it easier on my brain. We think better exponentially, guys. So I am going to change my logarithmic to exponential. I'm going to cross off log. My little 2 becomes big. So this becomes x up here, 32. You guys agree? They switch spots? Okay, so 2 to what power gives me 32? What is it? 5. Okay, scooting along. Let's look at 10. This one might be a little tricky. Log goes away. 27 becomes big, and then what happens here? X equals 3. Guys, we're going from a bigger number to a smaller one. So are we going to have a fractional exponent or a big whole number exponent? Fractional. Very good. What's the relationship between 27 and 3? All right, 9 times 3 is I agree. It's 1/3. How'd you get 1/3? If I say 27 to the 1/3, isn't that the same as saying the cube root of 27? What number times itself 3 times gives you 27? 3. All right, so here, what's the little number that I don't see? 10. Okay, so I'm going to go ahead, cross off log, put a big 10, and then these 2 switch spots. Okay, 10 to what power gives me 12? Anybody? Can we do this one in our head? So hit log 12. Tell me what you get. 1.079. Okay. Natural log. Natural log. If you were going to change this, guys, we'll talk about this a little more later, but if you were going to change natural log to exponential, look at your natural log button. What is the base going to become? When I cross off ln, there's no little number to make it big. What's the base going to become? Not a 10. Look at your button on your calculator. What's on the ln button? Is there a letter? It's e. Yep, so e to the x equals 0.75. We'll talk about that more later. You guys can't do that in your head. Hit ln 0.75. Tell me what you get. Negative 287. And that, ladies and gents, is part 1 of 6.3. So you have now, what, 15 minutes? Work together. Go to the bathroom if you need to, one at a time.